And we've got our sweep 1 distance, sweep 2 distance, sweep distance is R. Yeah, I was fortunate enough to get a job at Electronic Arts after all of the EA Wives scandal, where people were did a class action lawsuit against Electronic Arts for basically keeping people under desks and putting people under, basically hiring people straight out of college and then abusing the hell out of them because it was their first job. They didn't understand they can actually just like say no to your boss and go home. Which is pretty common for entry-level jobs. Like, you're in a shitty company when they treat entry-level people like garbage, because entry-level people usually don't know their worth. And will just get treated like trash and they don't even realize it. This would be outward nudge. And since I got into Electronic Arts after the EA Wives scandal and the class action lawsuit thing, they had to make everybody hourly who was entry-level employee instead of salaried. So it was pretty funny. After a year there, they promoted me. And I was like, I'm going to make less money now. And he's like, yeah, yeah, that's how this works. Like, this is bullshit. It's kind of funny that our mantling code actually works for this amount of ridiculousness there. Alright, so step 1 ray distance is 20, step 2 mantle failed due to 1 sweep. Okay, initial position was this position. Sweep distances are 23,855. Holy shit. Alright, well that's, there we go. Interesting. So this is actually correct. We should never have gotten down to this code though, because this is basically doing the projection vector of all the things. So what happened? Alright, so ray trace 1, so we should have, step 1 should take us up and over, and then we should be tracing into the wall. And tracing into the wall should fail because the step 2 rays should collide. So step 2 should be normal to the direction. Why am I wearing gloves? Oh no, another person asking the same question. Short answer, the guy in South Park who plays a whole bunch of MMOs. I totally played a bunch of MMOs in college, and as a result, I wear these. And other reasons, but yeah, basically they're just biking gloves. They help prevent the PC mark and the master race from developing. And I'm a fucking nerd, so that's another reason. Alright, so we should be failing because of step ray 2, so the start and the direction and the horizontal traverse. What is our questions here? So step 2 start and then step 2 direction. So what I want to do here is actually I'm going to disable the actual move. And I'm also going to start using my global utils here. Let's see, physics, physics trace tag equals text. Let's see, I want to call this mantle. And then after it, we'll call the reset on it. Reset trace tag. So I should be able to turn it on, like the character won't move anymore, I should be able to turn it on and see the race traces there. We need a clip for that? Yeah. Yeah, it's true. I should have a command there from Moobot, which is, you know, gloves. And I'm just kind of relaxing today. The ultimate golf clash. Yeah, it's just one of those things. Also, when I was working with people at different companies, you sometimes develop habits to kind of let people know not to bug you. So if I was like wearing my gloves and wearing my like gunner glasses and stuff like that, then people don't. Alright, we're just changing the physics trace tag. Right. Then people wouldn't come by and, you know, talk to me or something like that. Some people have. That was always a big problem with engineering and stuff like that. Somebody come by and bug you and pull you out of what you're doing, and then you can't concentrate and get any work done. It's always a big problem. Like, at the game companies I worked at, that was always a big deal. Would be teams would fail basically if they reached critical mass of interruption. So things like that. Thank you for following, Servothun. Just working on this game, Dashkin. Which is, if people are interested, and right now I'm just working on the movement and stuff like that. So okay, we're not doing that. I should do trace tag mantle. Oh, interesting. Interesting. It looks like what's happening is we are trying to mantle, but our mantling code is saying basically that that we would land here, so it's trying to mantle me. Like, basically the condition for mantling is hitting a different spot than the actual mantling position. Because we're using like this collision right here. Makes sense. Thank you, Servo. The artist that I'm working with is Adam Phillips. You may have known him from Fighty of Brackenwood, things like that. Won a lot of awards for his Flash animations and all that. So I am fortunate to work with that guy. Alright, so what is going on here that our step 2 start is our step 1 start plus this, and we're and our settle start is a sweep 1. We're taking our starting position so where does our step 1 start is our impact point plus blah. How did you link up with an award-winning artist? Well, basically, I was working on Dragon Age Legends at Electronic Arts, and Adam Phillips was one of the artists we work with. He had done stuff for Dragon Age Journeys and stuff like that. And he was always working remote in Australia, and I never talked to him because I was like a level 1 engineer, and you don't talk to artists that much, especially ones that are remote in Australia and do contract work. But basically, at one point, his server exploded, and he needed somebody to help him out, and he just like posted it randomly on Facebook, so I helped him out. And so we literally like don't really know each other. We are not like friends in real life or anything like that. We've never hung out and done anything together. But I just helped him out one time years and years ago, and then when we were working on some indie project, I quit Amazon and started working on my own projects. I noticed he was streaming on Twitch and was just like, hey, how's it going? And he had tried to make a Dashkin game with another developer like starting 5 years ago, and that went nowhere. So I was like, well, I'm now an indie developer and I don't have any art skills. Maybe we could team up. And he's like, that sounds like a good plan. So that's literally the entire story. Like, there was nothing complicated about us working together. Alright, so I need to actually focus here, don't I? Because I'm dealing with a bunch of math crap that's not working. So the step 1 start is actually the direction impact point and the movement sweep collision normal. But when we actually move, we're using the new position, not the sweep. So step 1 start. What are we using for our sweep? It's just new position plus normal to collision? I guess maybe step 1 start is the wrong thing here. We should be using just like the new position as the step 1 start for this thing. Let's see if that does it. We're like mortal enemies. Yeah. It's pretty funny. He's got like this series of pictures that he took when he was over in San Francisco for like 2 weeks or something. It's literally the only time he was over there. And I remember him in the office, just like, it was like, okay, this guy who's been working remotely showed up, so he was there. I was aware of him. But he's got like this series of pictures that he took when he was on vacation, and there's like other people in these pictures that were coworkers, but there is not a single picture where I'm in it. It's pretty funny. It's like, here's my whole vacation, and like everyone else on the team, and then just not me. So it was pretty entertaining in my mind. Alright, so that didn't do anything. Alright, so what is this supposed to be? Let's just come back from basics. So the step 1 start is supposed to be, like when we did this, it was basically like this. The step 1 start, like we're supposed to basically take this point of collision, cast it up, take it over here, and then discover that we can actually go here. So step 1 should basically be like where we are, up and to the left, which is our movement sweep collision normal. Like we take our actual position, take our collision normal. I mean, this is supposed to be the movement direction impact point is correct. Like the impact point is basically where we touch the wall or whatever. Maybe I should just throw a breakpoint in here and see exactly what it's doing. What a concept. See if all these distances are what I think they are. I mean, the ray distance is supposedly correct. It's just that this... Did I not compile this? Yeah, different from the original version. Because I changed the movement direction impact. Alright, so it's step 1 ray distance. So why is... Impact 3. So the impact location was step 3 start equals step 2 start plus step 2 distance times... Let's see what this is going out to. Can you visualize the positions and sweep paths? Yeah, that's what I was doing there, but they're like way off the screen for the sweeps. So we got 2 hits, one was a blocking hit and one was a non-blocking hit. Oh! So the non-blocking hit was on floor 88 and the blocking hit was on floor 90. Holy shit, okay, so I had this totally wrong. So, this is... this is floor 88, and this is floor 10, and this is floor 11. So what we were hitting for our thing here our step 3 hit is actually floor 10. So, alright, this is what's going on. It was when I introduced one-way platforms. What's going on is I'm taking the wrong index into the array for the mantle code. It's actually hitting this object way down here, and it's saying, okay, well, we can mantle appropriately. We just have to it has to do with the distances and all this stuff, and it's basically assuming that we were impacting here, but it's basically trying to mantle us over there, and as a result, we're just going way the hell up here, and that distance is the distance between those impact points. So this is a bug right here, where we need to grab the correct hit from our hits array, and it's depth sorted. Our hits for ray tracer, basically we want to, if we are mantling, what do we want to do with this? I guess our step 3 distance needs to be something different than physics far enough. Step 3 distance should be I guess we could just say the step 1 distance. It should be the step 1 ray distance. Just like that. And let's add like a small amount to it just to compensate for any imprecision. So that'll make it so it can't actually cast a ray and do crazy shenaniganry. But this other thing here needs to take into account a lot of things. What exactly do we want to do with it? Like, this is mantling, so if we're moving along a surface here, we're basically trying to stick to the surface. So if you're holding the down key, it doesn't matter, but we're on the ground. So the only thing we should be doing here is, I think we should just be taking the first hit in the hit array. So I guess it's just Sub-Zero right here. So we can do 2 fixes on it and see if that works. Because there's a few things with one-way platforms, and the one-way platforms are basically they're not blocking for raycasts and stuff like that. So you can like look through them, kind of like a window where you register the hit, but you don't actually stop the ray trace. For like, you would use this for like seeing somebody through a window, where you'd be like, okay, well we hit the window, and like this person can see through windows, and the ray trace would actually hit like the wall or whatever was on the other side of the window, and it would block on like an actual wall. So the final thing in the hit array should be a blocking hit, but we changed it, so... It's interesting. Yeah, and we would expect us not to be able to make it over this because we have disabled the actual mantling code that actually sets our position. So let's go ahead and get rid of a whole bunch of this debugging garbage we added. Alright, so maybe this will fix what we were having troubles with. Maybe. Maybe not. Alright, well, let's see if it does what it's supposed to do. Yeah, you can see it's doing what it's supposed to there, just dunk. With a little bit of mantling magic. Alright. Let's just go bomb around a little bit and make sure the movement code's still working as it should. Because we changed stuff. Let's pop over to our more complex test level for movement and see how that works. So it's, I think, move test. Where's camera test, move test. There. So we run like this. That works. We can run through that. Run through like that. And if we hold down, we run right through it. So we can run all the ways there. Alright, so what happened there? I'm having problems with... Like, we're still having problems, it looks like, with falling through terrain. Yeah, this is happening if I hit A and then I hold down and release A. I can fall through. So it's not mantling or anything else related. It's going to be related to probably the logic for the player controller, actually. Alright, so the issue is so what exactly is this issue? Well, that's how it's supposed to work. That's alright. Holding down is just supposed to work there. Okay, so there's a different issue. And this has to do with it's really interesting that hitting that down key is somehow changing our behavior. Hello, Adam. You feel like you're working. Well, thank you, Lois83. Yeah, I'm scratching my head at the moment, looking at Unreal Engine is now hosting me with up to 4 followers. Well, I'll try not to swear as much as I normally do, which is usually a lot. Or complain about Unreal Engine, which I do a lot also. I mean, if you're going to complain about something, you might as well complain about something real. Alright, so let's take a look at the output log. We're enabling it. Are we ever disabling it? Just like that. Alright. So why are we're falling through our one-way platforms right there. Was there any disabling? No. So I have to figure out why I'm falling through these things. And I don't exactly know why that is. There. Only because you love it so much? Yeah. Alright, so what we've got right now is we're on the ground, and I think it has to do with this one right here, so let's just confirm that this is what we want. I'm just going to set the startup map to the collision test map instead of the camera test. Alright. Let's recompile this and see what we got. Complaining organizers, don't worry. So I think it's going to be this collision here where we've got our current position and we're casting down, and it's basically the sweep has us already starting inside of the floor for some reason. And we were figuring out why that was beforehand, and what we had done is we had changed our snap to floor to actually move us a little bit up. So we weren't resting directly on the floor, but we were resting like 2 centimeters above the floor to prevent that from happening. So and that was before we fixed the mantling code. So what it might be is that we need to increase that so we actually get put on the ground properly. Yeah, it's totally that one thing that I made hours ago. That couldn't possibly be the problem. That's happened quite a bit. All right, so let's try to, because we switched from the raycast being precise, being what we didn't have complex traces on, and we turned that on, and all of a sudden like stuff started not working. Of course, now I can't get it to reproduce the issue. There it goes. So we are no longer on the ground, just like that. And it's because I hit the down key. So what happens when I hit the down key that's different? Because something is definitely happening there. Like when I hit the down key, the only thing that we're really changing is key down right here is we're setting our direction Z to be -1, and we're passing that into our thing, so our wanted velocity vector is going to change. But that shouldn't change anything. And that breakpoint was that our current velocity was anything. Like, we're not even using our movement velocity and direction. Yeah, it's just not even an issue. So this collision is just like hit. It was a non-blocking hit, and our ray distance was 100,000. Our collision distance was 957. So what actually happened was, yeah, we didn't even hit the thing that we're looking at. So, all right, I guess we're gonna have to just add a whole bunch of garbage code here and figure out what's going on. So we just normally landed, I think, is what happened. So it might be that we just need to change our penetration distance to something a little bit larger. So let's just try that real quick, because move ourselves a little bit farther out. We had some numbers in there that were adding up to not what we wanted. Sorry, I've got this penetration distance. This is how far off of the surface of the object that we're going to put ourselves when we snap our character to the ground. We don't want to be directly on the ground, because then we're inside of the ground pretty much. So we're a hockey puck on a superconducting surface track that has been frozen to absolute zero. So we're just hovering there. So same thing. I want to see if this penetration distance is working at all. So let's just make it something gigantic, like 30 centimeters. So we should actually see him just hovering there, because I want to see if it's actually working. And usually when you're doing movement stuff and collision or something, and if stuff isn't doing what you want, it can be real difficult to debug it. Sometimes if you throw like a gigantic value in there, it's easier to just be like, is this actually working? Is this number that I'm messing with and thinking does this action, does it actually do that action? So we should see him sitting nicely on top of the ground. And we're trying to do all of our movement here based on sweeps and traces and stuff like that against the physics in the world, and then moving our character ourselves, as opposed to like making a physics grid or something else. Mainly because, okay, so we're no longer on the ground. So our floor stick distance, yeah, we're getting stuck. I love how I can actually move. and all that. I can just glitch through everything. So it is actually moving us up, which is good. So we probably just need like a smaller number here. But let's go ahead and make sure that we're not going to ghost through that platform. So we had update snap to ground. Which was basically update snap to floor is what's should be calculated every frame here. And we're still like, that just doesn't look right. Like, that doesn't look like he's 5 centimeters off of the floor. So let's see, the surface normal. So the collision was, it did collide, the collision distance was 5.4. Let's see, the normal to the collision was, the impact normal was 1 in the Z, which is straight up, which is exactly what it should be. The distance was 5.5, which is what we would expect it to be. So what we're trying to do is we are so what is this? We're going to be moving in the Z, so it's 1105 is the suggested new position, and the current position was 1105. So that's reasonable. That's like what it's supposed to be. So that's what we're setting ourselves to be. So that should be 5 units off the ground. It's collision distance. We're actually going to move ourselves down by 0.5 is what it's. I mean, the other thing here is we could, instead of moving ourselves to the object, we could take the collision point and then move ourselves up from it. Maybe that's what we should be doing, and maybe I have an error in my math here that's screwing things up. So why don't we try the opposite real quick and see what that does. Well, the impact point is, it's not the impact point. Let's look up the definition of this real quick, actually. F hit result. So let's see, the impact point is the location of the actual contact. The location is the world space where the moving shape would end up against the impacted object it hits. We actually want the the location. Alright, so we want the new position is basically going to be the collision point plus negative down times the pin distance. So that should basically take the collision point and move us up by a certain amount off of it. Might have an issue with, like, it's not moving us off of the object in a normal to the surface fashion, so maybe that's what's going on, is we're moving ourselves up. But I mean, it really shouldn't matter that much. Like, if the thing's at an extreme slope, sure, but it'd have to be a vertical slope for there not to be any sort of movement. So why don't we just try this and see if that does what we'd like. And we're here coding at 3 in the morning my time, which is always the best time to do work, is in the middle of the night. That's what I do. I blame Adam for that. It's not Adam's fault though. I'll blame him anyway. It's because he's in Australia, and Australia has, like, you know, it's on the other side of the world. Like, in terms of not only the actual other side of the world, but the other side of the world. Like, you know, water flushes the opposite direction because Australia's upside down. I usually ask him, like, Adam, how are you not falling off the planet? And then he's usually just, he responds with a scream. And then I'm like, oh yeah, that's right, it's Australia. What was this for? Yeah, this is just snapping the ground. So now we're just constantly sliding around. That's really funny. So why is he sliding? Let me just take a look at this real quick. What have I done? The blame, I'm used to it. Here it's 12 a.m. Yeah. So the suggested new thing is collision point. So the hit location, interesting. So the hit location Alright, so the collision point is the hit location, which is at negative, because we're going to be moving in the y-axis, so we should be looking at our y's. Negative 26,144.7. And then our new position is at negative 26,145.5. So our location for our impact is actually saying that we're going to be moving to the, it's less negative, so it's moving to the right. So we'll slowly move to the right, even though we did a downward trace. It's still giving us, you know, the wrong location here for this. That's what it looks like. So the documentation of this location here is not correct. So why don't we just compute this instead of doing it otherwise? Let's just do the collision point should be the new position plus down times the collision distance. So let's not trust the documentation, because it's obvious that something is not correct there with the trace or the sweep. So We can trust our own math to actually tell us what we're doing, which has been pretty consistent. Like the stuff returned by Unreal for some of the sweeps and traces and other things has not always been what I expect it to be. Maybe that's my fundamental misunderstanding of a few points, or math being math, or something else that I'm not sure of, but there's a few things that are correct, which is usually like the collision distance and stuff like that, but the locations and impact points and other strange things aren't always what I think they should be. Probably because it's 3D space and it's giving me other conflicting information. But whatever. So it's still giving us not what we want. I mean, it's still this right here. I mean, we've got 1104.5 as our position, and we're supposed to go down, and the hit that we actually got was not a blocking hit. The distance was 1025. It's basically it's casting down and it's getting the thing that it's not supposed to be there. Is something else moving us? Something else must be going on here. The numbers aren't really adding up. Because we should definitely be above our surface there when we're snapping to the floor. Which is what we do right here. And this is how this movement code has just gone, and maybe I should have just picked a different tack entirely for the movement in this game than to use the sweeps and stuff like that, because it doesn't seem to be doing what we want. Just consistently. Z is at 900, the thickness is probably 100, so it's exactly at 100 or whatever.